Okay, we have here today another integral from the MIT Integration Bee 2022 regular season number 5. We have the integral of 2020 sine 2019 cosine 2019 minus 8084 sine 2021 cosine 2021 dx. Okay, I think this is going to be kind of an alternative method, although I can't exactly remember what I did last time, but I think this is going to be a little different. The first thing I want to notice on it is 8084. I wanted to relate that to 2020, but it doesn't quite work. So let's see, 4 times 2020 is 8080. So to get to this, 4 times 2021 is 8084. The other thing I want to use is when we've got the same kind of pattern here with sine and cosine. If we had 2 sine x cos x, this is going to be the same thing as, no, not that. This is going to be the same thing as sine 2x. So what I can do is kind of take this and just rearrange it a little bit. If I divide by 2 on both sides, we have this equation. Then each of these, we've got the same exponent, so we could kind of think of it like this thing to the n, then we just need to raise the right side to the n. So then what's going to happen for sine to the nx, cos to the nx, this is going to be the same thing as like 1/2 or 1 over 2n sine to the n of 2x. So what I can do is go back to our integral and deal with this part here and here and rewrite it in this form. And then from here, writing it this way, now we can do some factoring because we have actually this term, we could pull this out of this here and just leave like sine squared over 2 to the 2. So how this is going to work, I'll bring this 1 over 2 to the 2019 out front as a constant. And then I'll just factor out this part here. So we'll factor out sine to the 2019 2x, and what's going to be left is going to be 2020 minus 8084. And then for this part here, all that's going to be left is going to be just sine squared 2x, and here this is going to be, the numerator is going to be just 2 to the 2. I'm just going to write this as a 4 right now. But then I can go back to what we have right there. 8084 is 4 times 2021. Then I can cancel out the 4's right here. And don't forget a dx on the end. And sorry, I don't think I wanted to factor that. I'm going to do like the most inefficient step and I'm going to multiply it right back in. Sorry about that. So what's going to happen, but I will break this up into 2 integrals and I will still leave this factored out front. So for 2 integrals, the first one I'm going to have 2020 out front here as a constant, and we'll just have sine 2019 2x. And then for the second one, okay, we're going to have a minus in between. We're still going to have 2021 as a constant. Multiplying this back in with here, I'm going to kind of write this a strange way. Let's do this as sine, because we're going to go back to sine 2021. Let's split it up like sine 2020x times just sine of x. But actually, sorry, this is 2x here. Let me correct that. You might be able to tell that I'm disorganized on this one. My notes are kind of all over the place, so that's kind of why I'm making a lot of mistakes. I'm going to try to do better, so let me try to clean things up a little bit. And then the reason for splitting up the second one this way is I want to use integration by parts on it, because I'm doing it, I kind of created 2 things for our integration by parts. So I'm going to clean it up and move this stuff to the top of the board, but I'm going to put some labels first. What I'm going to want is, I'm going to call this integral here I, and we'll call this integral here j, just for convenience to keep track of what's going on. Okay, for integration by parts, we'll do this using the DI method or tabular integration over here. It was an easy choice. I want to differentiate sine to the 2020 to the 2x, because this one's going to be hard to integrate, but we can integrate sine 2x. So we'll go ahead first and differentiate, and what we're going to get is 2020 sine 2019 2x just with power rule. Because it's going to be a long expression, so let me write it on 2 lines. So then we need chain rule on sine 2x, that's going to be cosine 2x. Chain rule again, and that's going to be a 2. I'll just bring this 2 out here. Integrating sine 2x, that's going to be minus cosine 2x over 2. So we've got part of the solution here on the diagonal. And when I say solution, I'm just talking about j right now. So our j value is going to be this stuff from the diagonal. And then all this row, this is going to be an integral. But first, what's going to happen is 2's are going to cancel. Minus times minus is plus. So this integral is going to be plus. 2020 will bring out front as a constant. So we'll have 2020 sine 2019 2x. And then this here, and then cosine times cosine is going to be cosine squared 2x. But then over here, cosine squared, we can use the identity. I can write this as 1 minus sine squared 2x. But then I can distribute this into this expression right here, and we can rewrite again. So for our whole j expression, we have this first part. Both these are going to have 2020 in front, so it's going to be 2020. This first one, we're just multiplying by 1, so it's just going to be sine 2019. And for the second one, we'll use the minus sign, so we'll have minus 2020. And now sine 2019 times sine squared, that's going to become sine 2021. But then what we notice is this thing right here, this is the same thing as our I integral. And then this thing right here, remember you put this back together and it's going to be 2021, so this is the j integral. So what we have here is we're saying j equals this thing plus 2020i minus 2020j. Let me make a little space and we can first solve it for j and then plug it back in and finish it off. Okay, so from here what I can do is clear this 2020j. I can just add 2020j on both sides of the equation. So what's going to happen, this is going to cancel here. On the left side we end up with 2021j times all this stuff here. And then in order to isolate j, I'm just going to divide off 2021 on both sides. But let me divide it in. So I'll divide it in on this term, and we'll divide it on this term. This will cancel here. And now we've got our value for j. Let me just plug this back in, and we can see if we can simplify it more. And now that we plugged our j back in, we can do some more cancellation because we've got 2021 in front. So distribute that in. 2021 is going to cancel here and here. But then we can do more distributing in this minus sign. Now we've got 2020i minus 2020i. This cancels, distribute the minus sign in here, and now this becomes a plus. Sorry, it's a mess, but let me clean it up so we can see what's going on. But now writing it this way, we've got 2 as a common base here. In the denominator, I can multiply those together. 2 times 2 to the 2019, I can write as 2 to the 2020. Then all I need to do, just add a plus c, and that's it. So I kind of like this solution, maybe just because I'm feeling lazy, but actually MIT has it a different way. They put it back to the single angle. So what we can do is use that double angle formula again. So for sine 2x, I can write it as 2 sine x cosine x to the 2020. And then cosine 2x, there's three ways to write it that I know of. I can write it as 1 minus 2 sine squared x. But notice when we break this up, we're going to get a 2 to the 2020 here. Well, that's pretty nice because that's going to just cancel out with this. And so I can just take this and kind of distribute it back in here. So what we're going to get is, so what we'll get distributing it out, we're going to get sine 2020x cosine 2020x minus 2 times sine 2020 times sine squared. That's going to give you the 2022 that they probably wanted. Sine 2022x cosine 2020x. Add a plus c, and that's it. Okay, there you go. Good one from MIT 2022. Thanks everyone for watching. Have a good day.